that's going to reinforce the effects of a tax that increases prices, right? So for example, in differentiated products Nash pricing, then when the price rises, the products become less good substitutes. That reinforces the price rise. And so that makes this formula larger in that model than it would be just in the interpolation between the monopoly and perfectly competitive formulas. Okay. So again, this can be used to summarize lots of problems like procurement, taxation of trade, and many others. So let me just give you a little graph that shows this interpolation. Basically, you can think of the oligopoly model as just having a marginal revenue curve, which is a fraction theta of the distance between the demand curve and the marginal revenue curve. So if theta is 1, the marginal revenue under oligopoly converges to marginal revenue. If theta is equal to 0, it's exactly equal to the demand curve. And so if we get an increase in the marginal cost under linear demand, that leads to a larger pass-through under competition than under monopoly, right? Because the marginal surplus is declining in price, increasing in quantity, right? And so under competition, you get a large pass-through. Under oligopoly, you get what's in between, and under monopoly, you get the smallest one. Because the weight that we put on the monopoly-like behavior is proportional to theta. Okay. So one thing to notice is that the deadweight loss for a small increase in quantity, in exogenous quantity, is smaller under oligopoly than it is under monopoly. It's only theta times m dq here, right? Intuitively, the reason why that's the case is that when you increase your quantity, sorry, what was I going to say here? Okay, so under monopoly, the reason why the deadweight loss was the markup that you had times the change in quantity is that all the consumers were substituting to a good that was perfectly competitively supplied, right? On the other hand, under oligopoly, some of the consumers are going to be substituting to goods that firms earn a markup on, right? And therefore, you can have real externalities on other firms when they're having markups that can partly offset any of the harms that are created by you decreasing your quantity on consumers, right? So the real way that you should think about the externality, the harms created by a firm reducing its quantity, is not the markup that it charges times the change in quantity, but the markup that it charges minus the average markup of the goods to which consumers substitute when it fails to make a sale times the change in quantity, right? So directly under Bertrand competition or indirectly through strategic effects under Cournot competition, this markup of the goods that you substitute to is partly offsetting the harm that comes to society from you reducing your quantity, right? Now, under symmetric oligopoly, that's just going to proportionally reduce the deadweight loss. But deadweight loss is still going to be positive, right? But things get more interesting when things are not symmetric, right? Because then some firms might have a higher markup than other firms do. And Chrissy, what might that mean?
Well, if they've got varied markups, then you could
Yeah, and what does this formula tell us might be possible? Yeah, exactly. So it could be that if other firms have much higher markup than I do, that it could actually be beneficial for me to reduce my quantity. Under monopoly, it's always harmful for me to reduce my quantity because my markup's always positive, and that's the only thing that I'm affecting, and all other goods are perfectly competitively supplied. But I could have a positive markup, and still other firms could have a higher markup than me, and therefore it could actually be beneficial for me to reduce my quantity. And that could happen because of differences in the cost structure between firms. It could happen because of difference in their conjectural parameters or how strategic they are, whether they sort of assume that prices will stay fixed even though they won't stay fixed, or because of differences in product quality. So anyway, I don't think I really have time to go through the asymmetric case very much, but the basic idea is that, for example, if you were in a duopoly where one firm's product was of much higher quality than the other firm's product, the higher quality product is going to have a bigger markup than the lower quality product is. And therefore, it can be very often harmful to have the lower quality product in the industry. Because basically, if that lower quality product reduces its quantity, it loses a small markup, and the other firm gains a large markup. And that's actually beneficial. So the real thing we should be thinking about is not that firms should have markups driven to zero, but that the sum of the markups dotted with the changes in quantities that the firms induce should be set equal to zero. And so the general version of the conduct parameter is exactly that. It's when the firm changes their strategy, what's the effect that that has on quantities, dotted with markups, divided by the negative of the effect that the firm's change in strategy has on prices, dotted with quantities. Anyway, you can read the paper to go more through this, and I'm happy to talk about it at office hours as well. Sorry I didn't get to finish up today.